Hey, welcome to day 12 of live coding. Yeah, day 12. So let's go see what our day 12 problem is. Digital plumber. Walking along the memory banks of the stream, you find a small village that is experiencing a little confusion. Some programs can't communicate with each other. Programs in this village communicate using a fixed set of pipes. Messages are passed between programs using these pipes, but most programs aren't connected to each other directly. Said programs pass messages between each other until the message reaches the intended recipient. For some reason, though, some of these messages aren't ever reaching their intended recipient, and the programs suspect that some pipes are missing. They would like you to investigate. Go through the village and record the ID of each program and the IDs with which it can communicate directly. Each program has one or more programs with which it can communicate, and these pipes are bidirectional. If 8 says it can communicate with 11, then 11 will say it can communicate with 8. You need to figure out how many programs are in the group that contains program ID 0. For example, suppose you go door to door, record the following list. In this example, the following programs are in the group that contains program ID 0. Program 0 by definition, program 2, program 3, program 4, program 5. Therefore, a total of 6 programs are all in this group, all but program 1, which has a pipe which connects it to itself. How many programs are in the group that contains program 0? So let's see what the input looks like. This sounds like a pretty sounds like a graph search. So let's write up a graph search. D12 pipes.py, and as always, I will copy the URL and stick it in the doc string. And I worry that by solving it as a graph search, I'm going to screw up part 2 because part 2 might be something different, but whatever. So let's figure out how to parse one of these lines. Parse line. Line is going to be a string, and it is going to return. So that's what it looks like, and it is going to return. How do I want to call this? I'll just do a tuple of an int and a list of int. So from typing import, I could do like a fancy type, but I'm not going to use these for anything, so I'm not going to use a fancy type. I'll just do this, and I'll say, source targets equals line.split, something like this. And targets equals int x for x and targets dot split, and it looks like they're splitting on a comma like this, and return int source comma targets. And so assert that parse line of, and let's get this guy here. So we just want to assert that it returns the right thing, and it's kind of an ugly type, but I don't really care. 2034. So let us run that. Run day 12 pipes.py. Name tuple is not defined. That's easy to solve. And so that's parsing the line correctly. And so now what we want to do is we want to, so let's look at this here. It says 1 to 2. And are these correct? So 4 says 2, 3, and 6. That means that 2 says yes. So def, build graph lines is going to be what will I call this? I'll just call it a list of strings. And it is going to return a dictionary whose keys are ints and whose values are list of ints. And so this is not going to be super efficient, but that's okay. I'm just going to say graph dict int list int is empty, for line in lines, source and targets equals parse lines, and graph source equals targets return graph. And then let's put in this, this test input. Test input equals this thing. And let's just print build graph of, test input dot split on new lines. That should be okay. And let's run it again. Name dict is not defined. So let's try this again. List has no attribute split. Parse line. Okay, so 0 goes to 2, 1 goes to 1, 2 goes to 0, 3, 4, 3 goes to 2, 4. That seems right. And so now here is reachable from source, which is an int, and this is going to be let's do a set of ints. So we need a set up here, and so what do I want to do? So this is going to be a standard. I'll do depth first search because I don't really need. It doesn't matter. I can do either. So let's say frontier equals source, and reachable is a set of ints. Is just going to be an empty set. So while frontier is not empty, what are we calling these things? They're programs. So program equals frontier.pop. So we'll just pop this thing off, and so we'll say reachable dot add program, and then we'll say, so we need to put a graph here too. So graph is a dict from int to list int. Okay, so if we have a graph and we have a source, and I'll just set a default value equals 0, because that's what we want it to be. So for next program in graph.get program, and I'll just do this so that if I get someone who doesn't have any connections for some reason, it'll just get empty. If next program, we want to avoid empty loop. So if it's in reachable, is not in reachable. So we haven't already dealt with it yet. We want to frontier.append next program, and then return reachable. So let's do test graph equals build graph of, what did I do before? Test input dot split on new lines, and so let's just print reachable from test graph and see what happens. And we expect it to be 0, 2, 3, 4, 5, 6. So basically everyone but 1. So let's see what happens when we run it. If next program, kind of tired today, so I might make stupid mistakes. If next program is not in reachable, 0, 2, 3, 4, 5, 6. So it seems to be doing the right thing. So this is a very standard depth first search. Start with this source and add it to this frontier of things we want to explore, which is going to be a stack. if we were doing breadth first search, it would be a queue. And then while that stack is not empty, pop the top thing off of it, say we know how to get here, and then look at all of its neighbors based on this graph. Basically, if we haven't seen them before, add them to the frontier. And if we've seen them before, then we don't need to add them again. And then we just keep going. And so here, what we would do with the 0 is we say 0. This might be actually interesting. Let's just print what that frontier looks like at each step. So we start at 0, and then from 0 we can get to 2, and then from 2 we can get to 0, 3, 4, but we've already been to 0, so we just add 3 and 4. Then we pop off 4, and interesting. Why do I have? I'm adding things multiple times here, which doesn't hurt us, but I really would rather not do that. So let me do this. And next program, not in frontier. Okay, so then now I want to add things twice. Good. So we start with 0, and then 0 gets us 2. We're done with 0. We add 2. 2 gets us to 0, 3, and 4. We've already been to 0, so we don't look at it. So we do 3 and 4. We pop off 4. 4 goes to 2, 3, and 6. We've already done 2. And 3 is already in the frontier, so we just add 6. 6 will get us to 5, so we put that there. 5 can't get us anywhere we haven't already been. Then we're back to 3. 3 can't get us anywhere we haven't already been. So yeah, so I think that's good. So now let's go look how many programs are in the group that contains ID 0. So let's save as day 12 input.text. So assert that reachable from test graph equals 0, 2, 3, 4, 5, 6. I think that was right. And I don't need to, well, I'll leave the print frontier. That's kind of nice. So now here's our main equals main, with open, what do I call it? Day 12 input.text as f lines equals line.strip for line in f, graph equals, what do I call it? Build graph from lines, and what do I call it? Reachable from, so group equals reachable from graph 0. I mean, I defaulted to that, but we'll do it again. And so, print group, print length of the group. And it should be pretty verbose with my stack there. Actually, it's not that verbose. So again, I start with 0. Oh, actually, these are. I'm going to comment this out for a sec and run it again because I don't want to see those. They'll confuse me. So I start with 0. This says 0 can go to probably 1352 and 1864. So, 1352 and 1864. And now it looks like 1864 must be able to go to 1195 and 1239. So let's go to 1864 and check him out. 4 goes to 0, 1195, 1239. So we had those. 1239 must go to these guys, but also 1731. So we keep adding these. And then we've got 169 people in that group. So that seems like a good amount, 169. And let's just make sure that we read the problem properly. 6 programs are in the group of program 1, just the pipe connects it to itself. How many programs are in the group that contain program ID 0? So let's say 169. That's the right answer. 1 gold star closer to debugging the printer. Return to day 12. Part 2. There are more programs than just the ones. The rest of them have no way of reaching that group and still might have no way of reaching each other. A group is a collection of programs that can all identify via pipes, either directly or indirectly. Programs you identified just a moment ago are all part of the same group. Now they would like you to determine the total number of groups. Okay, well, so this is why I had a weird suspicion they were going to do this. And so that's why I put this source in, because now what I can do is the following. So let's write a function for this. Num groups graph, which is a dictionary from int to list int. Okay, and let's say ng equals 0. Or here, I'll call this count groups, and then I'll say num groups equals 0. And so what do I want to do? Seen is going to be a set of int, which is going to be an empty set. So I want to keep track of things that I've seen, basically. So for source in graph, so this is just going to go over, you know, the nodes in the graph. So what do I want to do? If source is not in scene, so if we've already seen it, we don't want to do anything, and you'll see why in a second. So let's say group equals reachable from graph and source. Okay, so I'm going to find all of the things, and scene dot append. No, what can I do with a? I want to. I don't know all the sets. S dot. Can I do union 1, 2, 3? Does that work? Yeah, that seems to work. Okay, good. So scene equals scene dot union of the group, and group is group a set? That is a set, actually. So I can even do scene like that. That's pretty good. And num groups plus equal to 1. So let's comment this out. Print count groups of test graph. And it's returning none because I did not return num groups. That's why we test these things. And it's saying 2 groups, so that's good. And now let me get rid of this print frontier and do print source in scene and print group. So I get to 0 and it says I haven't seen it yet, so here's its group. Next I go to 1, that's its group. I've already seen 2, already seen 3, already seen 4, already seen 5, already seen 6. Okay, so that is pretty reasonable. And I hear someone walking around upstairs, which is probably a kid. So we might get interrupted by a kid real soon. So print count groups of graph. And now let's run it and see what happens. And it says there's 179 groups. So let's just scroll through and see what it's doing, just to make sure it makes sense. So, you know, here's the group with 0 in it, and here's the group with 1 in it, and here's the group with 2 in it. 3 we've already seen. Here's the group with 4 in it, here's the group with 5 in it, and so on and so on and so on and so on. So that seems pretty good, and then by the end we've already seen most everyone. except for Mr. 1987. So this is saying 179 is my number of groups, so let's try 179. That's the right answer. 1 gold star closer, and got rank 857 in the stars leaderboard because it's soon after it started. So you know, I have done a lot of graph search problems in my lifetime, and I conduct a lot of interviews, and so I ask a lot of graph search problems. So graph search problems are things that I am good at doing and am fast at doing. So that was a good one. And as always, here I am at Joel Grus on Twitter. Find me, check me out, and I'm feeling very low energy right now, so I apologize if the video is kind of low energy, but I'm tired. And thanks for watching. I will see you next time.